All right, welcome. This is the first lecture of the new era, of the online era. This is actually take 4. I tried to record it 3 times already and wasn't happy with the results, so we'll see, maybe this time it will be somewhat better. And I'll start with reminding you about what's going on and what are our goals in this course. And then we'll talk about graphs, and then we'll talk about how to represent graphs in Python. And that's my goal for today. Okay, so first of all, let me remind you about our long-term goals. So basically, eventually we want to build some interesting models of, say, disease propagation in the population. So we want some network, some processes, a model for processes on networks. So, I mean, disease and pandemics are obviously on everyone's mind right now, but it doesn't have to be about that. It may also be about, say, propagation of news or moods and emotions through a social network on Twitter. So people are following each other, and then a news emerges, so a trend emerges, a hashtag, or maybe even an emotion. Or a viral video, and then it propagates through the network because people repost it, comment on it, then they start subtweeting and just mentioning it in some more hidden ways. So interesting things may be happening there, and the dynamics of propagation through the network, if you think of it, will obviously be pretty similar for viral videos and for viruses. So it kind of has this like hardcore, almost military application in epidemiology, but it can also be used in social science. So what we want to build, anyways, we want to build a model, a way to play with these models, with things happening on networks of people that are connected to each other, some of which are connected to each other. And if you think of it, so what can these models include? We probably want to be able to characterize these networks in some way. So we will want to be able to tell measure, describe some properties of these networks. For example, maybe some people have lots of friends, some people have fewer friends, some people interact a lot, some people don't interact that much. Some people can form sort of groups and cliques. Maybe there is political polarization. Maybe some people are only friends within a group, but are not friends, are very rarely friends with people from some other group. So we want to be able to quantify all of that somehow. So we want to be able to describe networks mathematically. I guess their properties. Describe some of the important or interesting properties of networks. Mathematically, we can remove that. Yeah, so these are our long-term goals. But in order to do that, obviously, we need to learn to create networks. So create interesting networks. And by interesting, I mean realistic, maybe, or something at least that has something to do with reality. Networks that resemble networks from real world in some way. But for that to happen, we need to learn to represent networks or graphs in Python, right? And so before we do that, we need to have a quick reminder on what graphs are. So that's basically our plan for nearest few weeks, maybe 2-3 weeks. And today we'll start with first two little steps. quick reminder on graphs and how to represent them in Python. All right. I'm recording that on Twitch. I'm also recording it locally so that I could upload it later on YouTube. So let's go and talk about graphs. What are graphs? A graph is an abstract mathematical concept that's basically, usually it's easy to draw. That's what's nice about them. It's a bunch of points that can either be connected to each other or not. So this is, for example, a graph. This graph has 2 points, and the official name is nodes or vertices. So this is a node or a vertex. And can I like move things? Oh Lord. No, I don't want this to happen. But okay. And this is an edge. Okay, I really want to learn. Oh, look, I can move them. Can I delete things? I can delete things as well. Yep. Okay, so we have a node, and it's connected. In this case, we have 2 nodes, and they're connected with an edge. And that's a graph. So here's another graph. This is a really boring graph. It has 1 node, no edges. Still a graph. Here's another graph. We'll have 5 nodes, and every node will be connected to every other node. Like, all of these are connected, and also this is a satanic graph. Just joking, nothing satanic about it. So this graph is called this graph is called a fully connected graph, and it's also kind of boring. I guess not as boring as this one with 1 node only, but while this one has no structure at all, this one kind of has too much structure because everything is connected to everything, and you can guess that real life graphs are probably not like that. So in real life graphs, some connections are present, but not all of them in most cases. So let's draw some graph that's kind of small but fun. This is small but fun. Let me use different color for edges to make it more fun. So here's a graph. It has 4 nodes, it has 4 edges, and if you look at it, it's more interesting because it has some diversity. Look, some nodes have 1 connection only coming into them. Some nodes has 2 connections. This node has 3 connections. So nodes are different. Also, we have an interesting structure here. So around here, we have a thing called a cycle. So there is an edge, and you can walk on these edges and return back to the same point, which is nice. This thing is called a cycle. Sometimes I make a mistake and call them a loop, but actually loops are different. Loops is a special kind of edge that is a connection of the node to itself. This is called a loop. Let me name that. So this is a cycle. We like cycles. And this is a loop. We don't like loops. I mean, in some cases, there are cases when loops may be important. In some applications, loops may be important. But I guess if you're trying to represent a social network or a network of interactions between people, then probably loops are kind of redundant, because obviously every person is always in contact with themselves, and you may follow yourself on Twitter or you may not, but it's not that important. It doesn't add too much, it doesn't affect what you're trying to do too much. So we will kind of remember that loops theoretically exist, but we'll see whether we will ever need them. Okay, so these are the graphs. How to represent a graph in a computer, in Python, in code, because these are nice drawings, but what can we do with those? So as a first step, we can try to just name the nodes somehow, let's enumerate them. Let's like put numbers. So in mathematical books, they like numbering nodes starting from 1. So there are 4 nodes. You will finish at 4. But because I secretly know that we're about to code that, let's actually start with 0 as programmers do. So 0, 1, 2, 3. It doesn't matter. It just looks less mathy, but it will look more programmy, and it will help us. Okay, so there are 4 nodes from 0 to 3. How to describe which edges exist and which edges don't? Let's just write them down, all of the edges, and then in Python you can imagine it. We can create a list of lists or a list of tuples, something like that, a list of pairs of numbers. So one pair of numbers is 0, 1. This is like this edge. So this edge is there, and then 0, 2 is also there. I don't have a pen, so I'm drawing with a mouse. Makes it more fun. So 0, 1 is there, 0, 2 is there, 1, 2 is also an edge that's present in this graph, and finally 2, 3 is also an edge. And you can see that if you find a way to store and manipulate and like do things with these 4 pairs of numbers, then we will be working with this graph. So this is the way to represent this graph. How exactly we number the points, whether we start with this node or whether we start with this node, it kind of, most cases probably doesn't matter, because like this graph and this graph are essentially the same graph, right? They have the same shape. So the sequence in which you number the nodes doesn't really matter. It only matters that the shape of the resulting graph is what it is, what you want it to be. All right? Okay.